Hey everyone, and welcome to This Explainer. Today, we're taking a really fascinating journey to demystify the cloud. We're going to be moving step by step from the bare metal, nuts and bolts architecture all the way to the financial bottom line. Whether you're an IT student or a business decision maker, understanding this blueprint is absolutely crucial. So let's break down the mechanics and the economics and see exactly how it all fits together. Here's our roadmap for today. We'll start with the architecture layer, move into the NIST ecosystem, check out the design playbook, and wrap things up with the bottom line, cloud economics. All right, let's dive right into section 1, the architecture layer, where we build the foundation. So, cloud computing is basically made up of many loosely coupled components, but we can broadly divide this entire architecture into two main parts that are connected by the internet, the front end and the back end. Think of it kind of like a restaurant. The front end is the dining room and the menu. It's what you, the client, actually interact with, right? Like your web browser. The back end, though, that's the kitchen and the pantry. It's the cloud itself. It holds the massive data storage, the virtual machines, and the servers that actually prepare and deliver whatever service you just requested. Now, the really fascinating part of this back end is a specific piece called the hypervisor. If the back end is our kitchen, the hypervisor is essentially the head chef managing all the equipment. It's a firmware or a low-level program that acts as a virtual machine manager. And what makes it so spectacular is that it allows a single physical instance of a cloud resource, like one massive physical server, to be shared among several different tenants at the exact same time without them ever interfering with one another. It's literally the secret ingredient that makes resource pooling possible. Supporting that hypervisor is a whole suite of essential infrastructure components. We've got the servers, which compute the resource sharing and handle security. We've got the storage devices. And here is a crucial detail. The cloud keeps multiple replicas of storage, so if one storage resource fails, your data is simply pulled from another one, making the whole system incredibly reliable. Then we have the network, which connects it all together, kind of like city roads, even allowing customers to customize their own network routes. And finally, management and deployment software are always working behind the scenes to maintain, configure, and seamlessly integrate applications into the cloud. Moving right along to section 2, the NIST ecosystem, covering the rules and the citizens of the cloud. Let's shift gears from the hardware to the actual framework that governs how all this operates, because we need to understand what makes a cloud, well, a true cloud. The National Institute of Standards and Technology, or NIST, defines 5 essential characteristics that are basically the gold standard. First up, on-demand self-service, meaning you can set up your environment without ever calling tech support. Second, ubiquitous network access. You can get to it from any device, anywhere. Third is location-independent resource pooling, where resources serve multiple consumers dynamically. Fourth, rapid elasticity, so you can scale up or down instantly. And fifth, pay per use. You only pay for the processing or bandwidth you actually consume. Honestly, if a platform doesn't have these 5 traits, it's just not a cloud. And this environment is populated by 5 major actors, according to the NIST Cloud Reference Architecture. The communication paths between them are actually pretty complex. You have the cloud consumer and the cloud provider, which are the main players you probably already think of. The consumer requests the service, and the provider manages the infrastructure to deliver it. But here's the thing. They definitely do not act alone. There are 3 other roles that act as absolutely vital intermediaries. As cloud integration gets more and more complicated, a cloud broker steps in to manage the use, performance, and delivery of services. They essentially negotiate the relationship between consumers and providers. Then you have the cloud auditor. They perform independent examinations to verify that the provider is actually meeting security controls, privacy standards, and compliance regulations. And finally, the cloud carrier. They act as the transport agent, providing the physical telecommunications pipelines that shuttle all those cloud services back and forth. Okay, on to section 3, the design playbook, the building codes for the cloud. So now that we know the actors and the rules, how do we actually build the environment? Well, a complete cloud architecture design is a step-by-step process based on 6 core principles. Step 1 is reasonable deployment, choosing the right setup, like maybe a hybrid architecture to balance local compliance with public cloud power. Step 2 is business continuity, ensuring your services literally never stop. Step 3, elastic expansion, make sure loosely coupled systems can scale up during big traffic surges. Step 4 is performance efficiency, which is all about maximizing resource utilization. Step 5 is security compliance, protecting against attacks and keeping your audit logs intact. And lastly, step 6 is continuous operation. setting up really rigorous monitoring and alarms for all your cloud resources. I want to zoom in on Principle 2 for a second, business continuity, because it is incredibly critical. It relies on two concepts that people actually mix up a lot, but they serve very different purposes. High availability is proactive. It uses redundancy, like deploying your servers across different availability zones, to completely avoid business interruption when a local resource fails. Disaster recovery, on the other hand, is your reactive safety net. If your primary operating environment is heavily damaged or compromised, disaster recovery is the protocol that restores your applications and data in a totally different environment. To truly survive, you need both. Which brings us to our final section, Section 4. The bottom line, cloud economics. Okay, so we've built our robust, highly available cloud architecture. But how do we actually pay for all this? Well, cloud billing is incredibly flexible. If you have an unpredictable short-term project, you're going to use the pay-as-you-go model. You're billed by the hour or minute with zero upfront commitment. But let's say you know for sure you need a server running 24/7 for a database. For that, you use reserved instances. By committing to a 1 to 3 year term, you get a massive discount. And finally, if you have flexible workloads that can tolerate being interrupted, you can literally bid on spot instances. These are unused cloud resources available at incredibly low rates. The only catch is the provider can reclaim them if the market price exceeds your bid. Understanding these trade-offs is exactly where true cost savings happen. Mastering your total cost of ownership, your TCO, means actively managing those pricing models. And two of the best ways to do that are right-sizing and auto-scaling. Right-sizing is exactly what it sounds like, looking at your workload and making sure you aren't renting a massive virtual server when a tiny one will do the job perfectly. Auto-scaling, though, works dynamically. It automatically adds more servers during high traffic periods, and, even more importantly, it removes them when traffic drops back down. Using both of these techniques together prevents you from paying for over-provisioned idle resources. To manage all this effectively, providers offer some pretty incredible dashboard tools. Take AWS Cost Explorer, for example. It allows you to view up to 12 months of your historical billing data completely free of charge. You can use it to spot spending trends, forecast what you're likely going to spend over the next year, and even get automated recommendations for purchasing those reserved instances we just talked about. When you pair that with tools like AWS Trusted Advisor, you have complete transparency to audit your entire infrastructure for both peak performance and cost efficiency. So, we've journeyed all the way from the physical servers and the hypervisor, through the NIST ecosystem, right down to the dollars and cents of TCO. And I want to leave you with this final provocative thought. With rapid elasticity, spot pricing, and advanced cost explorers right at your fingertips, are you still paying for cloud resources you don't even use? It might just be time to take a hard look at your own architecture and start applying these strategies today. Thanks so much for joining me on this explainer, and keep learning.